Hello friends, welcome back to our normal revision for the Mathematics KCSE the year 2023, paper 1. So today we are looking at question number 20. Reads as follows. Nema went to a market to buy bananas worth shillings 2,100 for a school. The seller offered a discount of shillings 3 per banana, which enabled Nema to buy 35 more bananas. But A taking X to represent taking X as price per banana before discount, write an expression for Roman 1, the number of banana that Nema would have bought before the discount. Now this topic is called a quadratic application in quadratics. This is form 3 and basically a little bit is introduced in form 2. So how do you express that? The main thing, one, we have this amount 2,100. So if I want to buy bananas and the price is unknown, the number of bananas that Nema is going to buy before the discount automatically becomes the amount she has divided by the amount per banana. So this one is the expression. Part B, actual number of banana that Nema bought after the discount. So after the discount, Nema bought 35 more bananas. So we have 2,100 x. Therefore, we are going now to add 35 more bananas because after the discount, that is what happened. However, you are supposed to note very well that after the discount, there are always two equations that are supposed to be formed. Let us look at the next part. Form an equation in terms of x and hence determine the actual number of bananas. So to form an equation, it means they want you to write the two equations after the discount. So one equation is here. The other equation will affect the number of bananas bought. So the number of bananas bought after the discount becomes the price over x, you are told, a discount of 3 per banana. A discount of 3 and x is the price, so the discount means subtraction. So this is one of the equations that took place. It affected the amount and this one affected the total number of bananas bought. Therefore, we are going to equate them as equal. So you say that this one, it is equal to that equation. So now we have two equations that are equal because they are equations that took place after the discount. So just to solve this one, I'm going to put over 1. Then I find the LCM of the denominators. The LCM of the denominators, it means I'm going to multiply by whatever I see in the denominator. For the upper part, I'll multiply by x minus 3, x, and the value 1. That is the LCM. Same to this one, I'll multiply by 1, x minus 3, and x. Here also 1, x minus 3, and x. So this will cancel, x will cancel x, and 1 will cancel 1. So on top here, I'll have 2,100x is equals to 2,100 in bracket x minus 3 plus x, if I write 35 first, x and x becomes x squared and x and 3 becomes negative 3x. So just to make the equation more smaller, I'll divide both sides by 35 by 35 by 35. So I have 2,100 divided by 35. That will give me 60. So this case I have 60x is equals to, if I open the bracket here, it is 60. So it becomes 60x minus 180. Then plus, there's no change here, so x squared minus 3x, because here I'll have 1. So if I bring this one this side, it becomes a negative. So this one will cancel that one, become a negative. So I'm left with an equation here as x squared minus 3x minus 180 is equals to 0. To solve this one, it is now a quadratic equation. I can use any method, either the completing square method, either the quadratic method, quadratic formula, or the factorization. So I'm going to use factorization. To use factorization, we are going to look for the sum and the product of negative 180. Which two factors, if I multiply, I'm likely to get 180, and if I find the sum, I'm likely to get negative 3. I realize that if I look at all the factors in between here to consider, it is factor 12 and factor 15. So where do I put the negative so that this one becomes a negative? If I bring a negative on this side, this will be a positive, so I bring it on the other side. As to proceed from here, I'm going to substitute this expression into this part. Now, at this point, there is no penalty for using any method for solving quadratics. Therefore, I'm going to replace and say x squared plus 12x minus 15x minus 180 is equals to 0. You realize that it is only this part I have substituted with the part B. It is always this part A, part B, part C. So to group this one into two, I'm going to look at the factors. X is common here and here, so x goes here and here 12 times. The same equation here. 15 will go here, x, and on this part being a positive 12 is equals to 0. These ones in the bracket has to be the same. Therefore, x minus 15 and x plus 12 is equals to 0. So I'll say x minus 15 is equals to 0, which gives x to be 15, and x plus 12 is equals to 0 will give me x is equals to negative 12 if I bring these ones the other side, just to cross the other side. So I'm told to hence determine to find the value of x. So I'm not going to ignore the negative one because we cannot have negative bananas. It is very impossible. So we're going to have 15 as the correct answer. So you are told determine the actual number of bananas named about. Now the actual number of bananas bought, it is on the expression Roman 2, the actual number of bananas. So I'm going to take 2100 divide by x. For this case I take x as 15, then I add 35. Therefore the actual number of bananas becomes 175 bananas. So that is the right answer. Now to the last part. The bananas were given to students in a school. 2/3 of the students got 2 bananas each, while the rest got a banana each. So this is very simple. Taking the number of students to be let, student is equals to x. So 2/5 of x got 2 bananas, and the rest left in the equation, which is 3/5. This one should give me 175 bananas. Here I have 4/5. X plus 3/5x is equals to 175. So we have to add, it is 7/5 because the denominators are the same. So to find the value of x, I'm going to multiply by the reciprocal. 5/7 times 5/7. X is equals to, if I press this one on the calculator, so x is going to become 125. Therefore, the number of students are 125 students. Look out for more on this, and if you have any challenge, inform me so that we can do more. That was quadratic in Form 3. Thank you very much.